Let's look at the solution of episode 17. Smith Joker assigned 5 numbers 2, 3, 4, 5, 6 to 5 different boys A, B, C, D, and E, not necessarily in the same order. B is assigned the number 2. Then Smith whispered 7 distinct numbers C1, C2, C3, C4, C5, C6, C7 in that order, one at a time. The sum of these 7 numbers was 100, and each of them was greater than 2. Okay. The sum of C1 and C2 was 30. Okay. He did not whisper 6 and 7. He never whispered 6 and 7. Exactly one of the numbers whispered by him was less than 10. On each whisper, only the boys whose assigned number was a factor of the whispered number raised their hands. The table given below shows the process. Yes means the boy raised his hand. No means the boy did not raise the hand. And we have this table. First thing we have to ascertain is all the information that we have, what all does that actually means? B is 2. B is 2. If B is 2, and C1 and C2 and C5 and C6 and C7, upon this mention of these numbers, B says yes, it means this is even, this is even, this is even, this is even, and this is even, and these two numbers are odd. Okay, these two numbers are odd. This much you have to keep in mind. Additionally, what comes to our aid in such questions, or this question particularly, is look at this question too. What is the value of C4? I already have 4 possible values of C4. So let me just record it in an ascending order: 11 or 13 or 17 or 23. This is also identified. Okay. Now we know the first two numbers add up to 30. First two numbers C1 and C2 add up to 30. Now I am told that A, C, D, E, out of A, C, D, and E, values to be assigned are 3, 5, 4, and 6. These values are to be assigned. I know that the numbers are definitely multiples of 2. So anytime if a number is a multiple of 3 also, it will automatically be a multiple of 6. So any of these, can you see that D and E, you can happily identify as 3 or 6, 6 or 3, because if the number is divisible by 2 and it is divisible by 3, it will automatically be a multiple of 6. So say A, if it was 3, if A was 3, this is no, this is no, there should also be one other number. If A was 3, there should be, out of A, B, C, D, there should be one other number where you are getting a pair of no-nos. So that is not possible. D has to be a multiple of, D has to be either 3 or 6, and E has to be either 3 or 6. Only then it works. Okay. Another thing I identify, C2 is definitely a multiple of 2. C2 is definitely a multiple of 2. Now this is either 4 or 5. 4 or 5. Okay. How do I break this down? I know this number is a multiple of 6. I know C1 is a multiple of 6. C2 is a multiple of 6. I know it is a multiple of 6, One of them, if they are multiples of 6, how do I break it down? No and no. If both of these, if one of them is not a multiple of 4, okay. You cannot possibly have 5 as no, breaking down into no and yes. If C1 was a multiple of 5, let's say if C1 was a multiple of 5, because the summation is 30, C2 will automatically be a multiple of 5. So it is, when you're getting a no and a yes, it cannot be 5. So this also helps me identify C is definitely 4. If C is definitely 4, A is definitely 5. A is definitely 5. So now, what do I know about C2? What I know about C2 is, it is a multiple of 2, it is a multiple of 4, it is a multiple of 3, it is a multiple of 6, or it is a multiple of 12. So it can either be 12 or 24 It cannot go beyond 24 because the summation is only 30. Also, it cannot be 24 because if this was 24, this would be 6. And we were told that he did not whisper 6 and 7. So 6 and 24, this is not a possibility. The only case that works for C1 and C2, the only case that works for C1 and C2 is 18 and 12. Multiple of 2, multiple of 3 or 6, multiple of 3 or 6. Yes. So these values are uniquely identified for C1 and C2. Now we are looking at C3. C3 is a multiple of 5, but not a multiple of 2, not a multiple of 4, not a multiple of this and this. Okay. We were told that only one number was less than 10. Only one number was less than 10. Okay. Can I say for these five numbers, 4 of them are at least 10. So 4 of them would add up to at least 40. 4 of them would add up to at least 40. And then even if I assign everything to the fifth number, the largest possible value the fifth number can take, the largest possible value that fifth one can take has to be 30, can be 30. None of the variables can be greater than 30. Okay, so let's list out multiple of 5, but not a multiple of 2, not a multiple of 4, not a multiple of 3 or 6. Possibilities for C3 are 5 or 25. Okay. For C5, again, multiple of 2, 4, 6, and 3. 2, 4, 6, and 3. It cannot be greater than 30. It cannot be 12 because these were 7 distinct numbers. So it has to be 24. It has to be 24. Now let's look at option C6, multiple of 2 and multiple of 5. It has to be 10. It cannot be any other number apart from 10. Or can it be multiple of 2 and 5? Can be 10, cannot be 20. Can it be 30? Let's say if 30 was allowed, or 30 was the upper limit we had identified. No, if it was 30, then 3 and 6 will also become multiple. So no, this is not possible. C6 has to be 10. Left with C7. It is a multiple of 2, but not of 5, not of 3, not of 7. So it has to be some multiple of 2, which is under 30, not a multiple of, so it can either be 14 or 22 or 26. These are the possibilities for C7. Okay. Now we were told exactly one of the numbers whispered by him was less than 10. Among the available options, the only way it works is if C3 was 5, so this is also fixed. C3 is fixed, C5 is fixed, C6 is fixed, all of this is fixed. We are left with only these two. Let's see how much summation we are getting right now. 18 plus 12 is 30, 30 plus 5 is 35, 35 plus 34 is 69. Now I'm taking the min case, 11 plus 24. 11 plus 24 is 25. If I add it up, 69, 25, 94 I get. 94 I get. If I get 94, I know sum of the 6 numbers is 100. So I need some 6 extra. Can I get 6 extra here? No, this is 8 extra. Can I get 6 extra here? Yes, I can. So now I know for certain C4 is definitely 17 and C7 is definitely 14. I know all the precise values of C1 to C7. Each of these numbers is exactly known to me. And I also know A, B, C, D. Let's get to individual questions. What was the value of C3? Value of C3 was 5. What was the value of C4? Value of C4 was 17. Had Smith whispered on one more number valued 45, who would have raised their hands? 5 and 3, 2 gone, 4 gone, 6 gone. The people who have 5 and 3 would raise their hand. So 5 is A is definitely there. But between E and D, we will not be able to identify who will raise their hand. Therefore, the answer to the third question has to be indeterminate. Last question, which of the following could be the number that was assigned to D? Number that was assigned to D had to be 3 or 6. So option A, 3 could be a number that was assigned to D. And our entire set is done. This is one of the more fun sets that I have done in recent times, because identifying C1, C2, C3, there are lots of small little factors at play, and one of the most difficult things or most critical things in identifying here was the upper limit of 30 for the remaining 5 variables. Once you identify the upper limit of 30 for the remaining 5 variables, then the cases that you have to deal with goes down immensely. Okay, next question. 14 people are standing in a queue to buy movie tickets. Ramesh, a 17-year-old boy, is the last person in the queue. It is observed that there are 2 boys and 1 girl among any 3 consecutive persons in the queue. The booking counter opens at 2:45 p.m. A boy spends exactly 3 minutes while a girl spends exactly 4 minutes at the counter. The counter is closed for 12 minutes after every 6th person in the queue is done. Okay. And then we have questions. Let's see. So we have 14 people standing in the queue. So I will make a line. Then break it up into 14 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and last spot being 14. This is identified. Okay. Now, if this is the 14th spot, this is the 13th spot, 12th, 11th, 10th, 9th, 8th, 7th, 6th, 5th, 4th, 3rd, 2nd, 1st. I know 14th is Ramesh, a boy. If this is a boy, now the 13th spot can either be a boy or a girl. Can either be a boy or a girl. So I'm going ahead and writing down both those cases, either a boy or a girl. Now, if we take the case at the top, it is boy, boy, then this one has to be girl, because out of every 3, 2 boys and 1 girl had to be there. In 12, we automatically know it is a boy. Now looking at 11, 12, 13, 2 boys and 1 girl had to be there. So this has to be a boy. Out of 11, 12, 13, 2 boys and 1 girl. So this has to be a boy. 10th, 10, 11, 12. In the top, this will necessarily be a boy. But here we will necessarily get a girl. Now 9, 10, 11. This is boy, boy. So this has to be girl. This is boy, girl, boy. So hopefully by now you have seen the girl will always be 3 places away. This is how this filling out has to take place. So we've got at 10. So we'll get another girl here. We'll get another girl here and another girl here. So boy, 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 and boy. We have both the cases identified. We were also told that at the end of every 6 persons being served, there was a break of 12 minutes. So I'm representing that here. These are the 2 cases, 2 ways in which work is happening. Okay. What is the time Ramesh is expected to leave the booking counter? Okay. Look at it. In the top case, you have 1, 2, 3, 4 girls. In the bottom case, you have 1, 2, 3, 4, 5 girls. And boys and girls spend different amounts of time. Boy and girl spend different amount of time. So we will get different answers. And therefore, the answer to the first question has to be, cannot be determined. If the 4th person leaves the booking counter at 2:58 p.m., at what time will the 10th person in the queue leave the counter? 4th person leaves it at 2:58. So it starts at 2:45. So this becomes 2:48. Here it will be 2:49. Here it will be 2:51. Here it will be 2:52. Here it will be 2:55. Here it will be 2:55. Here it will be 2:58. And here it will be 2:59. So when they're saying the 4th person, they're talking of the case at the top. They're talking of the case at the top. Now the 10th person leaving, let's do. So 1, 2, 3, 4, 5, 6, 7. 7 into 3, how many girls? 1, 2, 3. So 4 into 3. And 1 12-minute break in between. So 33 plus 12-minute break in between. Altogether 45 minutes after the start. The start was at 2:45 p.m. So the person will leave the counter at 3:30 p.m. Done. Work is done. Wonderful. If Ramesh can take any position and the total time taken to buy all the 14 tickets is 1 hour 11 minutes, then what can be the time at which Ramesh leaves the counter? Okay. Total time taken is 71 minutes. Let me figure out total time taken. In the bottom case, I have 5 girls. In the top case, I have 4 girls. In the bottom case, I have 5 girls. So instead of working with this partial info, let me work with 71 minutes. No? 1 hour 11 minutes is 71 minutes. So 4 girls, 4 into 4 and 10 into 3 and 12 into 2. This is the total time taken. Here it is 16. Here it is 30. Here it is, sorry, 12 into 2. So here it is 24. So this is 70. In the first case, it takes 70 minutes. In the second case, everything is same except one boy has been replaced by a girl. So second case will be 71 minutes. Cool. So if it is 71 minutes, what are they asking? Then what can be the time at which Ramesh leaves the counter? Okay. So if it is 2:59 here, it is 3:02 here. Then how much time does the next person get over at? 3:05. Then the break of 12 minutes takes place. And 4 minutes. 12 plus 4, 16 minutes. So this is at 3:21. Then next is at boy. So 3:24. The next is again boy. So 3:27. Then 4 minutes. Then 3:31. Then 3 minutes. 3:34. Then 3 minutes. 3:37. Then 12 minutes. So 3:49 plus 4 minutes. 3:49 plus 4 minutes is how much? Is 3:53. And then 3 minutes, 3:56. 1 hour 11 minutes. Yes, absolutely fine. Everything is nice. So what did they ask me? If Ramesh can take any position and the total time taken by 2 hours 14, what can be the time at which Ramesh leaves the counter? Can Ramesh leave at 3:30? No, there is no time at 3:30 at which Ramesh can leave. So not possible. Can he leave at 3:29? No, there is no time at which person is leaving at 3:29. Can he leave at 3:34? Yes, he can leave at 3:34. So option C. Next, if Ramesh can take any position out of the given 14 positions and the total time taken to buy all the 14 tickets is 70 minutes. Oh, one important thing. Our entire cases were built on the idea that Ramesh is the last person is a boy. What if the last person is a girl? What if the last person is a girl? In that case, what would happen? I'll have to create a case for that and check timings as well. Oh, this has increased my work. Okay. If last person is a girl, I get boy, boy, girl, boy, boy, girl, boy, boy, girl, boy, boy, girl, and boy. This case would also exist. In this case, what would happen? After the second person, timing will match. After the fifth person, timing will match. After the eighth person, timing will match. So I have 3:24 here. How I'm getting to that conclusion is GB, BG, it will be 2:52 here. Then BGB or BBG, timing will match 3:02 here. Then whatever happens, everything is same. Here it will be 3:27. Here it will be 3:30. Yes. So the time at which Ramesh leaves the counter, possibly it can also be 3:30. So A and C both are possible. And I only got this trigger because of option 4. I only got this trigger because of option 4. Ramesh is no longer the last boy. Our entire case building was based on Ramesh being the last boy. That is no longer necessary. As soon as they tell me Ramesh can take any position. Okay, last question. If Ramesh can take any position out of the given 14 positions and the total time taken to buy all the 14 tickets is 70 minutes. So this case is being talked of. The one at the top. What time can Ramesh leave the counter? Okay, let's see. This is 255. This is 258. BBG 305. This will be 320. 323. Achha, BGG 327. This up until this point, everything is fine. Then next is 330. 333, 337. Then if this is 353, this is 353, 1 minute less than that, 352 and 355. Yes. What are the options available? 337. Is a boy finishing at 337? No, it is a girl. Is a boy finishing at 334? Nobody is finishing at 334. Is a boy finishing at 329? Nobody's finishing at 329. Is a boy finishing at 330? Yes. This boy is finishing at 330. So answer to the last question has to be option D. And that is the entirety of this question as well. Hopefully you learned something from this episode. That will be all. Okay, bye people.